Let's solve this problem. ABCD is a trapezoid. AD minus BC is equal to 14. We need to find the area of the trapezoid. Since ABCD is a tangential quadrilateral, by the Pitot theorem, the sums of lengths of its two opposite sides are equal. AB plus CD is equal to AD plus BC and equal to 28. Please find the link to my video with the proof of this theorem in the description below. Let's draw an altitude from the point C to the side AD and from the point B to the side AD. BCMK is a rectangle. BC is equal to KM. And since AD minus BC is equal to 14, AD minus KM is also equal to 14. Therefore, MD plus AK is equal to 14. AK is equal to 14 minus MD. Triangle ABK is a right triangle. By the Pythagorean theorem, BK squared is equal to AB squared minus AK squared. Triangle CMD is also a right triangle. By the Pythagorean theorem, CM squared is equal to CD squared minus MD squared. And since BK is equal to MC, because they are altitudes of the same trapezoid, we can equate these two expressions. We know that AK is equal to 14 minus MD. Now let's sub in the values, and after expanding and simplifying the equation, we are left with MD is equal to 9. The full explanation of how I ended up at this result can be found in the description below. Since triangle CMD is a right triangle, we can find CM using the Pythagorean theorem. CM is equal to 12. The area of the trapezoid is equal to the sum of BC and AD over 2 times CM. Let's sub in the values. BC plus AD is equal to 28. CM is equal to 12. The area of the trapezoid is equal to 168 square units. Thank you for watching. If you found this video helpful, please don't forget to like, share and subscribe to help my channel grow. Thank you.